Hello and welcome to our maths class again. Finally, we're on the last question, which is question 6 of our first math question. And we are going to solve the last question and see the good things that are there for us. Like I've said, I'm telling you that this time we are going to do what? We're going to make the grade A. Once we follow what we've done here, we'll get the grade A. Good. So we go straight away into question 6. You can see we have factorization for question 6a. We have the Pythagoras theorem for the question 6b. Then question 6c is an application of what? Of fractions. So we just see how we can do this. So we have question 6a. And the last time in our first question, we spoke of what? Factorization, how to do a factorization. In fact, the type 2 one. And this is exactly the type 2, a very simple type 2 as compared to what we saw in the first one. And this is what? Factorize completely. If you factorize completely, 6xy minus, let's enlarge in, let's bold in this 6xy minus 3y plus 4x minus what? 2. Factorize this. Now, these are 4 terms. To factorize, very simple. Group them into 2, the first 2 and the second 2. That's the first pair and the second pair. We are fine. So the first 2, second 2 are fine. So let's factorize here. Very, very simple. I just want to go quick here because we've already done the factorization. And I hope you have practiced more so we don't waste much time here. If not practice, then keep practicing your factorization. Like we said, the first question. So let's go. So 2 is common. Between the numbers, 2 is common. So I have 2. Y is also common. So Y also comes out. Then this gives me, I'm left with 3 minus y is out, 6, 2, so 3x minus, what do we have here? We have, no, let's change this thing. Let's change it. 3 is common instead. Let's 3 be common. So 3 is common. So since 3 is common, let's go. Since 3 is common, we have 3, y is also common, so y comes out. This gives me 2x minus what? 1. So this is how we go. 3 is common here. 3 goes into this, so 3 can go, so 3 will go. 2 initially could not go into this. So 3 goes here, goes here, so 3 is common. When we say common, and now that can go into the coefficient is common. Then the letter is common if it can be found here and there. So that is why we have it. And I always say copy this and paste it here. Just go and copy this and now paste it. So we have 2x minus what? 1. Let's copy. Don't worry yourself factorizing this. Now let's see. What do I multiply by 2 to get 4? That gives me what? 2. When I multiply 2 by this, I get 4x, and 2 by that gives me that I'm done. Then I come and check the sign. What sign I need? The moment to open this bracket, you should get the same thing here. So what sign do I put here to give me what I have here? When I put a plus here, positive 2 times, that will give me positive, and negative, that will give me negative. So that means this is right. Then from here, there is something I said earlier on in the first question once again, that those outside the bracket, put them in one bracket, and because these are same, they also be in one bracket. So this finally will give us what? 3y plus 2, then into bracket 2x minus what? 1. This is multiplication of 2 binomials. When I open this up, when I solve this, when I open this bracket, I have to get this. So this is the factorization. Very simply done, very simple. But I want to give you one more thing. The last time we did one factorization, let me put that one here. Say we have x minus y plus 2 into bracket, then we have here a plus c, then we have another one, another x, and let's say 2x plus y minus 4, and then we have another a plus c. So we should factorize this. When you have this to factor, I told you that like we did here, since these and these are the same, what do? We are going to pick one of them, then put these guys together. So that's what we did here. Those outside, I picked them together. But how did I know those were outside? I took those that were equal. So since this is the same as that, I'm going to maintain it as this plus that. Then I'm going to put these guys into one bracket outside. So that'll give me 2. That'll give me x minus y plus 2. Then plus what? Plus 2x plus y minus 4 into another bracket. I can simplify this. Don't worry about that. Let's simplify this. This give me a plus c into bracket x plus that will give us 3x. Then y, when that will go to 0. Wow. This and this will cancel this and it goes to 0 because of integers. Then this and this will give me negative what? 2. At the end of the day, this becomes what? My answer. The point I'm trying to make is that once this and this are equal, the rest, no matter how lengthy, put them in one bracket, and we fine. So that's how we solve question 6 for. A. Question 6A. Let's go to question 6B. Question 6B. Let's go to question 6B. And question 6B, like I said, is Pythagoras or theorem. So let me draw the diagram. I have a Pythagoras theorem here. Let me draw the diagram nicely for you. It's about an application of Pythagoras theorem, rather leaning against what? The wall. So I have P here, then that gives me B, and I extend this as a Q there. Okay, then this is A. Then from there to there, we're giving what? 6 cm. Then from here to B, we're giving 8 cm. We're giving 8 what? Cm. So this was the diagram, not drawn to scale. Okay, let's read. The diagram shows a ladder AB. A ladder AB, that's a ladder AB, which leans against a vertical wall. The wall is what? PQ, but it's leaning against that one at B. So there's a ladder AB, there's a wall PQ, the ladder leans against the wall at the point what? B. If I lean this against this board, then I form it from here to there, gives me what? Gives me what we have here. So this is my ladder, this is my wall, and this is the wall. The foot of the ladder away from the wall. The wall. Look at that. Okay. If our PB is 8 meters, if PB is 8 meters, so the unit is meters. If PB is 8 meters, if PB is 8 meters, and the other end of the ladder is 6 meters away from the foot of the wall. 6 meters, so this is the foot of the wall. Then the ladder is 6 meters away from. So the distance between this and this becomes the foot of the ladder. Find the length of the ladder AB. Let's find the length of the ladder AB. I said that the moment you have these two lines or lines meeting like this, then this one becomes 90 degrees. Therefore, this becomes our height. And any triangle that has 90 degrees in it can apply the Pythagoras theorem in order to solve it. So in order for us to find the length of the ladder AB, which is the hypotenuse of this diagram, then we are going to go back and quote that guy Pythagoras to solve this. Good. So we can say that from Pythagoras theorem, what do we have? Let's put the formula in terms of this. So we'll have AB squared, the length of AB squared equals the length of what? PA squared plus the length of what? PB squared. PB squared. So this is what we have. Now from the question we have PA. What's PA? 6 squared. Then PB is what? Is 8 meters. So we have 8 squared. And that should give us our length. What is 6 squared? 6 squared is what? That is 6 times 6, not 6 times 2. Keep this. Some of you make the mistake. You multiply this by 2 and you get 12. No. Anytime you see squared, so 6 squared means we multiply 6 2 times 6 by itself twice. So we have this, and that gives me what? 64. 8 is 64. And this gives what? 36. So this is what we have. Then we add this up, we'll get what? We'll get 100. But 100 equals AB squared. We want AB, not AB squared. We're looking for the length. So we square root both sides. So square rooting both sides, I'll get a square root of what? Of AB squared equals the square root of what? Of 100. It's a perfect number. If you look into the first class, we did this there. So this will cancel this. So we have AB equals 10 what? Meters. AB equals 10 meters. Therefore, what the question says we should find? So we should find the length of the wall of the ladder AB. Therefore, the length of ladder AB is 10 what? Meters. Very, very simple. Very, very simple. So we have that also solved. Very, very simple. So this is our question 6A. This is question 6B. So now we can now go to question 6 what? C. So look at question 6C. Question 6C. And C is in I and I. But this aspect of the question, I want to show you something here. So listen to this question carefully and look at it carefully. Because these percentage questions They normally try to bring this percentage and fraction question to confuse you, but as it works, very easy. Once you understand the principles behind it, most of these questions, the answers are in the question. I'll prove to you that the answer in the question, but you don't take your time to really understand that people have told you that these ones are difficult and all that. Don't listen to those things. You can do it if you understand the principle. So let's go. Question 6C. Kojo had 1,800 bags of rice in what is stock. And I've always advised students, you have a question like this, you want to solve, always write down the data or the parameters in the question. Don't mean to begin reading, write down to every point, interpret what you have read. You're putting the data down. You know why? It helps you to know. I always say, what are the things I have? What am I looking for? And I get it so easily, no matter how. That's the best way you can solve the question so far. The best way is to read to a point, write down the parameters. You can start by reading everything so you get a general idea of the question. After which you read to a point, don't start answering the question. Write down the parameters, by the end of the day, the answers will come out. The answers will come out. So just follow this and it will be good for you. Okay, so let's go. Kojo had 1,800 bags of what? Rice in stock for what? For sale. So that's my full stop. So I can say bags of rice to be sold. So bags. You can change these bags. That's how anyhow you want to write, but it makes sense. Bags of rice to be sold. Bags of rice to be sold. According to the question, we have what? 1,800 bags. So this is the first information I have, the first full stop. Good. Then we continue. In January, he sold 2/3 of it. People, the answer is here. Don't get confused. If the question tells you that Kojo has sold 2/3 of it, in your mind, what were you told? You were told that off means what? Multiplication. The it there is referring to what? The total amount of rice, of bag of rice that Kojo had. So if you tell me that he sold 2/3 of the rice, that's the answer. So I'm going to say that bags of rice sold in what? January. So you see, with reading this to the point, I want to interpret what I have read. That's how the math becomes easy. So I'll just write bags sold in January. I have read the question, but I'm reading to every full stop and trying to interpret what I have read. These are the principles here, people. When you get this principle, you're able to solve most of what? The question. The question says that it continues. In general, he sold 2/3 of it. What are we talking about? The bags of rice. So he sold 2/3 of what? Of the total bags of rice, which is 1,800. You tell me you can't do this. You can do this. You can do this. So let's go. We have 2/3 times 1,800. This will go into itself once and cancel the 600 times. That will give us 2 times 600, which gives us 1,200 what? Bags. 1,200 bags of rice were sold in what? In January. And that's this and that thing here. The moment you calculate for the rice sold, don't wait for the question to tell you. Go and calculate for the amount of what? Rice left. Bags left, or rice left or bags left. Anytime you are doing these are the principles I'm teaching you here. You are doing such a thing, you're able to read. Forget the question that you asked. I said read to every full stop and try and interpret, or the moment you take a breather and you're reading, interpret what you have read. Either a comma, a breather, or the full stop. These are the points. So I read by saying what? I said Kojo had 1,800 bags, so I wrote it down. 1,800 bags. Then in stock, in January, he sold 2/3 of it. Eventually, I get an answer to that. So these are the number of bags sold. So that I don't get confused. Okay, so let's clean this board so that we break this question down. I like questions of this sort because it allows you to think. These guys, we don't think here. We know the formula, we just put them, we are done. But these questions are just like them. And that's what WAEC has realized, that most of you don't want to do this. So they are now putting them in your set. In most of the things you do, they put them there, the easy ones you know. So you go and think. So let me teach you the principles and apply them. You are going to get this thing. You will get them. Okay. So these are the bags sold in January. So the moment you do that of January, go and find the bags left. So bags of rice left. Don't wait for the question to tell you. It's part of the principle. Anytime you find something, go and find what is left. You find the bags of amount sold. What is left? Fraction strength. What fraction is left? So you do that. So let's find the bags left. So bags left. Bags left to be equal to what the total bag is 1,800 minus what the guy has sold, and that will give me, let me do this common subtraction for you, minus 1,200, and that gives me 600 what? Bags. So now we are left with what? 600 bags. Then I continue the reading. I don't care what question I was asked. I've already read, but I'm interpreting this thing stepwise. Then I continue. In February, he sold 3/4 of what was left. So if I've not found what was left here, I'll find myself wanting. I'll be thinking, and that's how people get clumsy in your head and you get confused. Take your time. So you see the principle. After doing what? After find the bags sold, I automatically find the bags left. Keep it somewhere. And the question tells me that in February, he sold 3/4 of what was what left. So bags sold in February. So bags sold in February. Once again, it is what 3/4 of what is left. What bag is left? 600. It's very, very simple. So of what we have what? 600. So this is 3/4 times 600. 2 goes here. How many times? Or 4 can go into 1 going how many times? 150 times. Right? Or let me cancel with 2 and see if I get the same thing. Yeah, do the same thing. 2 go into itself 2, and 2 go into these that'll be 300 times. This goes here 1, it goes there what? 150. So I now have 3 times 150. So the same thing. I have 3 times what? 150. Then I multiply it by 150. So I know the bags that were sold in what? In February. So let's multiply 150 by what? By 3. This gives me 0. 3, 5 is 15. I put 5. Remember 1. 3, 1, 3 plus 1 gives me that. So that means in February we sold what? We sold 4, or he sold 450 there. Bags were sold. 50 bags were sold. Okay. Now, what fraction of the rice? Question CI. What fraction of the stock of rice did he sell in February? So now let's solve that for them. What fraction? So question 6CI. Now I have this question 6CI. What fraction? Let's know how many bags were sold in what? In February. That was 450 what? Bags. But one thing I want you to know, that when it comes to this kind of math that I'm saying, the principle once again, the total bags in terms of fraction is 1. We have that approach of making the work more easier. Now listen, the total bags of rice that he has, because it's a total, is always equivalent to 1 in terms of fraction. If you are working in percentage, the total bags is always what? 100. Keep that. So we are saying that if you want the fraction of rice sold in February, so this time when the fraction of rice sold in February, this will be equal to, we'll say, if the total bags we have, which is 1,800, equals 1, which is the total fraction, then what fraction does this guy represent? What fraction does this guy represent? Now listen to what I'm saying. I'll use this trick to solve most of your questions. So I'll come here and explain it to how I'm getting this. So you get a concept. When you have this, you can solve any of the questions. Any of the questions when it's percentage, profit and loss. With this ideology, you can solve almost all, but all of them can solve. So I'm saying that since this is a total, we are doing fraction, then total goes with what? Total. Total corresponds with total. Hence, total fraction equals what? Equals 1. If total fraction is equal to 1, then 450's fraction, what is that? Then we calculate. So this gives me what? 450 over 1,800 times what? 1. So this is what we have. Now let's go. 0 cancels 0. Now we have 45 over 180. 5 will cancel 45 how many times? 9 times. 5, 9. How many times will 5 go into this? Let's work that one here. So we have 5 into 180. 5 will go into this. 5, 4 is 20. So 5, 3 is 15. So 15. That gives me, when we subtract it, we get what? We get 3. Put a 0 down. 5 will go into this how many times? 6 times. So that means 5 will cancel this 30 what? 36. Then 9 goes itself 1 and going to this how many times? 4 times. So the fraction is what? It's 1 over 4. So the fraction of rice sold in February, therefore, the fraction of rice sold in February is what? 1 over the 4. 1 over 4. So this is the fraction of rice sold in what? In February. So this is how we solve that. So note that total bags is always equal to what? It's always equal to 1. So if this is 1, then this one, what is the fraction? And that represents what? 1 over 4. 1 over 4. Okay, let's go. Let's go. Now, the I alpha. So this is I alpha. So we are going to I C I beta. C I beta. That's 6 C I beta. C I alpha and C I beta. Now you want the what? The fraction of the rice that was sold in February and January. Okay, fraction of rice. Fraction of rice in January and February. Of course, what do? We have to add both the amount sold in what? In January and the amount sold in what? In February. So let's add that and we have what? So this is the fraction. Let's first of all write this one. Do this, we don't know. Fraction, we don't know. We'll say number of bags sold. So number of bags sold in January and February equals what? Number of bags sold in January and February equals, how many bags were sold in January? 1,200 plus February, which is what? Which is 450. So we have this. This gives me 0. That is 5. That is 6. That is 1. So we have 650 bags were sold. So we use the condition once again that if the total number of bags, which is this, equals 1, then 1,650 bags equals, what do we know? We don't know. So once again, let's go. So therefore we have what? We have 1,650 over 1,800 times what? 1. So this will cancel that. We'll have 165 over this. Let's do the long division here. 5 I'm going to this and this. How do I know? This ends with 5, that ends with 0, that 5 can divide. Let's try that here. 5 goes into 165. How many times 5 going to 16? It's 3 times. 5, 3, 15, 5, 4, 20. So we go with 5, 3. 5, 3 is 15. Then I subtract, I get what? 1. I bring a 5 down. 5 will go into 50 how many times? 3 times. So 5, 3, 15. Therefore, 5 will go into this how many times? 33 times. Then 5 will go into 180. We did it somewhere here. That's 36. So 5 will go into this 36 times. So we have 36. Okay. So now, still on the fraction, we have what? 33 over 36. 33 over 36. Now we cancel this. Now we cancel this. What am I going to cancel? There's no one to cancel this. 33. So that becomes our fraction. That becomes our fraction. Good. Now, how many bags of rice were left unsold by the end of February? I think now we calculated it. How many bags of rice were left unsold by February? We were left with 600 bags, and we sold 450 at the end of February. So how many is left? So bags left unsold. Now be the CII. So CII. Bags left unsold equals, after selling the 200, the 1,200, we left with what? 600. Then we sold this out of. So that will be 600 minus 450. 600 minus 450. And this gives me 0. I borrow 1. I have what? I have 10. So that will give me 5, then 1. So therefore, the bags left were what? 150 bags were left unsold 150 bags were left what? Unsold. So this is the end of what? Of our questions in the first math question. I'm very happy we are here now. We are at the end of what? The question. Once again, thank you very much for joining the class. You're welcome. You're welcome. Now, the next time you'll be getting more interesting things. We are going to go topic-wise, break down the topics for the BEC. Thank you very much, and we'll meet again in our next class.